Okay, so like I did with the other ones, I am going to draw pictures to represent these. Okay, so we'll go 2 different triangles. Okay, we'll go A, B, C, X, Y, Z. Okay, and in angle, side, angle, you would have a situation like angle A is congruent to angle X. You would have side AB is congruent to side XY, and then you would have angle B is congruent to angle Y. Okay, angle, side, angle. Remember yesterday we emphasized the fact that you're not allowed to skip anything. Okay, we're going from an angle directly to a side, directly to an angle. Okay, this side, similar to side, angle, side, is referred to as the included side. Notice it is the side that is basically formed by the 2 angles with the tick marks. Okay? So in order for it to be angle, side, angle, it has to be directly angle, side, angle. Bing, bang, boom. Okay? Questions there? You okay? Did you like that? No. Smiling over there. Okay? Questions there? All right? Angle, angle, side. Okay, for this one, draw another 2 triangles. I'll just use the same letters to be consistent. Okay, and for this, angle, angle, side. Angle, angle, side. Notice that in this case, the side is not in between the 2 tick marks. Angle, side, angle, it is in between the 2 tick marks with the angles. This time it is outside of it. Okay? Questions there? Alright, so then, quick little review. If I were to ask, okay, there are 5 ways to prove triangles congruent. What's one of the 5? Let's get 5 different people to answer. Laura. Side, side, side. 2. Maddie? HL. 3. Angel. SAS. 4. ASA. And 5. Mary? AAS. Okay? And those are all 5 ways. There are no others. So there is no ASS. Remember we talked about that yesterday. Okay? There is no AAA. Just because there's SSS doesn't mean that there's AAA. Okay? In fact, you actually saw that on one of our notes earlier in the chapter. Is one equilateral triangle always going to be congruent to another equilateral triangle? No, because one equilateral triangle, even though they're all 60, 60, 60, could have sides of 3, 3, 3, and the other equilateral triangle could have sides of 5, 5, 5. Okay, even though the angles are the same. Okay? All right, so here is your objective. Okay? You have to determine on the one with the building why the 2 triangles are congruent using any of the 5. Reminders, if not 3 things are marked, if 3 things are not marked, always look for something that can be assumed from the picture, like reflexive and vertical angles. Unless they give you parallel lines, then you can assume alternate interior, corresponding, so on, things like that. Okay? So in part A, what do you got? Laura. Okay? She says angle, angle, side. Now the first thing that's probably popping up into some people's mind is the fact that there's only one set of angles marked. Where the heck are you getting another set of angles? Very good. So she sees, oh, vertical angles are congruent. And so now it ends up being angle, angle, side. okay? All right? So remember, every once in a while, you're going to have to fill in some information. All right, B. What do we say on this one? All right, Kendra? No? Nate? What do you think? No? You know they're equal? Absolutely sure. Positively. If you are, then give me one of these 5. What? Okay, she says none of them. So if they're none of them, then she's basically saying that they're not congruent. So reminders, big idea, okay, that you have to understand. You always need at least one side. In SSS, there's 3 sides. In HL, there's 2 sides. In SAS, there's 2 sides. ASA has 1 side. AAS has 1 side. So if I go and look at this on Part B, are any of the sides marked congruent? No. So here they're trying to trick you with AAA, and I just got done saying AAA doesn't exist. Okay, so they're not congruent. All right? C. She says angle, side, angle. I need a set of sides that are congruent. Okay, she says the middle or the reflexive. And so now she's got angle, side, angle. Okay, so ASA. Okay? All right, so that was our practice doing it together. So try example 2 on your own. What are we agreeing on? What did your table say? AAS? 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 Anybody disagree? All right, so it should be AAS, okay, but the question then remains, where's the second set of angles? Charlie? Vertical angles are congruent, okay? All right, so remember, you always got to be able to back up your statement. All right, let's go to our proofs, the parts that you're probably most concerned about. Reminders, okay, you should probably have your card stocks out so that we can, you know, go through this a little bit more efficiently, okay? We have them, let's use them, okay? All right, let's do, like we said from the video, let's do a little strategizing here, okay? So it starts out by telling us that we have some angles that are congruent. So we're going to mark that in our picture, okay? We've got FGI is congruent to HIG. So FGI is congruent to HIG. Says FIG, I'm going to do with a different set of tick marks, is congruent to HGI. Okay? And then I'm out of givens. So now I got to be able to come up with something on my own. What are we going to come up with? Reflexive? Charlie says reflexive. Okay, GI is going to be congruent to GI. All right, so now that you have your strategizing done, you got 3 different congruency things there. Why are the 2 triangles congruent? Which one of the 5? ASA. Okay, all right, so to shorten this up, remember we said if your 2 givens are exactly the same, you could put them on the same line. So FGI is congruent to angle HIG. Angle FIG is congruent to angle HGI given. Okay. Then Charlie said GI is congruent to GI. And hopefully you understand that's reflexive. And double checking, let's see, I got a set of angles congruent, a set of angles congruent, a set of sides congruent. So I'm basically done. I can now go triangle FGI is congruent to triangle HIG. And you all said ASA. Okay? Remember, you have to use 3 letters. Angle ACB is congruent to angle DCE. all right? So if you're going to do vertical angles, you got to use 3 letters, because angle C has 4 angles, all right? So be specific there. All right, so we're good with that one. Given, VATAAS, all right? All right, let's go down to the bottom. We'll do the last one. Okay, again, with your strategizing, think about this. AK is congruent to CJ. You got your angles congruent. You got another set of angles congruent. Reminder, I talked earlier about sometimes it helps to maybe trace the 2 triangles you're trying to prove congruent, because there's a lot of triangles occurring here. Okay, so for example, I know that angle A is congruent to angle C. That's an angle in both triangles. BJK is congruent to BKJ. Those angles are congruent, and they're both angles inside the triangle. And then this bottom side of the triangle is congruent to this bottom side of the triangle. So tick, tick. So why are the 2 triangles congruent? All right, how about this? Do we have enough information to say the triangles are congruent right now? Do we have 3 congruent statements from each triangle? Yes, we do. Okay? If you need to, separate it. Okay? This is B, K, and A. Okay? And we've got this angle, and this side. And then over here, we've got B, J, C, and we've got this angle congruent to this angle. We've got this side congruent to this side, and we've got this angle congruent to this angle. So now that I separate the 2 triangles, why are the 2 triangles congruent? Anybody? ASA. Okay, so we know it's going to be ASA, and in fact, you don't even have to come up with anything beyond given, given, given. They gave you everything. You just have to recognize that triangle ABK is congruent to triangle CBJ by angle side angle. Okay? So just another hint for you, if it helps, think about separating the triangles when you go to do this. Okay?